So we're doing optimization problems, but the very first step that you should do is read the problem. You might have to read it 3 or 4 times, but you're going to need to read the problem. You're going to probably need to draw a picture. The rest of the stuff we'll go through as we go through a problem. This is for those of you who like to have a step-by-step process. The hardest part is going to be step 7, finding the domain. I call it a natural domain. So here is our first problem, classic calculus problem. We've done this before. And what we're going to do is we're going to take a piece of cardboard, 24 inches long by 9 inches wide. So this is 24 and this is 9. And I'm going to cut out the corners and make a box. I want all these to be the same. I love these problems.
Yeah, this is way better than doing like.
So I'll do the best I can. Oh, I think what's going to happen is you're going to say, I wish we were doing that stuff from 4-3. It was a lot easier than this.
Great. I'm so excited.
We're only doing 1 day on this. Okay, so I cut the corners out. They're all supposed to be the same size. I will fold it up. And I will have an open box. Not too bad. Get the idea. Oh, look at that. They're helping me. I love it. That's good. And me teaching with an iPad, it'll be a little different. Okay, so that's what it is. I want to find the biggest volume here. I was waiting for that. How do you find the biggest volume? What's volume? Okay, so we took out these little pieces right here. Yes. You don't want to do it if they're not, because it's harder then. So what's this length that's left? Well, that's 24. This whole length is 24, but I cut out 2 of the corners. Right, 24 minus 2x. Okay? Tom? Yep. What's this side? You have a length of 9, but I cut out these 2 little corners.
9 minus 2x.
Yeah, the little piece is 9 minus 2x. The hard part is, of course, finding the formula that you want to maximize. The calculus is not that hard. The calculus is just taking the derivative. Getting the problem set up is where it's hard. So what is the volume? How do you find the volume of that box? It's length times width times height. So it's what? 9 minus 2x times 24 minus 2x times x. And darn, if I had my CAS calculator, I could multiply it all out without doing it by hand. But it's not working on my computer. And my regular Inspire, it won't do that. So what you did last year, and you would just put this on your graphing calculator, wouldn't multiply it out at all, and you would just graph it, and you'd find the maximum volume. That's what you did last year. The hard part was coming up with this. There's the second hard part, finding the domain. Well, we got to multiply that out. So what's 9 times 24? I would choose to do these binomials first. It's 216. Okay, now what are you going to get? Minus 48x. Okay, you guys should be doing it with me. And then minus 18x, right? Plus 4x squared. And we're going to multiply that by x. This is all algebra, no calculus.
Okay, so first foil.
I foiled first. It's easier to multiply.
Right.
To me, it's easier. And now I'm going to simplify and distribute that x. Can I do all that at once? Okay, so it's 216x. Now when I add these together, what am I going to end up with? No, they're both negatives. I wish. Minus 66x squared plus 4x to the what?
3.
Okay, all my exponents look good. Okay, that's all algebra. The calculus is the easy part. What's v prime? Because remember, where do max and mins occur? They occur at endpoints if I have a closed interval. Is this a continuous function? Yeah. I'm going to close that interval. We'll do that in a second. So what's the derivative here? Minus 66 times 2. 132x plus, take the derivative of 4x cubed, 12x squared. Can I factor anything out of that? Because it would be easier to factor. Well, certainly 2. Well, let's see. 2 plus 1 is 3 and 6, 9. So 3 goes into this. 4 and 2 is 6. Let's try 12. How many times does 12 go into 216? You guys doing it in your head or are you using a calculator? Okay, how many times does 12 go into 132?
11.
Plus x squared. Okay, I don't like that backwards. Do you? So v prime equals 12, and it's x squared minus 11x plus 18. Okay, that's much easier. Whew. I just don't like it backwards. I didn't learn it that way. So, who said they like the factoring? This is factoring. I got to factor that. This is x and x. What are they going to be? Minus 2 minus 9. Okay, so where is this? Yes, Sasha. I multiplied it out and then I took the derivative and I'm factoring the derivative. I'm not factoring the function. Oops, I copied this. Did I make a mistake further back? No. There's no other way to do it, unless you want to use quadratic formula. You got to find out where this is 0. It's 0 is x equals 2 or x equals 9. Okay, if I have a closed interval, I don't have to do a first derivative test. We can close the interval. And it's going to bother you, but we're going to do it. Well, I come back here to my picture. What is the smallest this corner can be? Smaller. Well, you can't cut out a negative number, right? This is a natural domain. X has to be greater than 0. Now, because the rest of it is just mathematics, forget the geometry for a moment, we can include 0. Because if x is 0, we don't have a box anymore, do we? But you can go as close to 0 as you want. We're going to include it. Because then I can do the math that says the maximum existence theorem says I have both a max and minimum on that interval, if I can close the other side. Yeah, minimum volume would be 0, because what is v of 0 if I put it in right here? You could do it in a table or you can write it here. What's v of 0? That's 0. Obviously that's a min, so my two numbers down here would be good candidates for the maximum, just like the Iowa caucus, which they almost did all tie, by the way, except for Michelle Bachman, who was the minimum, right? Does that start to make sense? They're candidates. Doesn't mean you're going to win. Okay. We got to close the other side of that interval. Is it 9?
Yeah.
If you put 9 in here, I get 9 minus 18. That's going to be a negative number, isn't it? Well, what's going to be true about
4.5.
what's going to be true about this side? That's right. 9 minus 2x also has to be a positive number. But we're going to do, we'll include the 0 because that will give me the other endpoint. That's right. 24 minus 2x must also be a positive number.
Yeah, but that's
I said we could have. But that won't, but Tom, don't forget, we got to find all the candidates. Do you know how to solve this? I'm going to add 2x to both sides. Doesn't really matter how I do it. And divide by 2, which is perfectly okay. So x has to be smaller than 4.5. So there's my interval. 0 to 4.5. What does this one give me? If I solve this one, I get 24 is greater than or equal to 2x dividing by 2. X is smaller than 12. I have to have the most restriction that's there. Because even though 10 works here, will 10 work in this expression? That's just my iPad. I've got Facebook or who knows. Okay, if I put 10 in here, does it work on this 9 side? Can x be 10? Just look at it logically. Can x be 10? No. So my numbers have to be between 0 and 4.5. What is v of 4.5? Just put in 9 halves here. If I put in 9 halves, what happens to this factor? It's 0. That's right. So what happens when I multiply that out? It's 0. I'm guaranteed, this is the best thing about this theorem, I'm guaranteed I have to have a maximum. So it either has to occur at 2 or 9. What's wrong with 9? Look at your interval. What's my interval? It goes from 0 to 4.5. Is 9 in my interval? Nope. So without even doing any more work, I know that gives me the maximum value.
The other interval from the 24 minus 2.
You can't, because it has to be the most restrictive one. We can't use the 24 because that means x has to be smaller than 12. So try 11 in here or 10. This side won't work. I take the smallest, most restrictive interval. Yeah. Why what? No, you have really the x is smaller than or equal to 12 and x is smaller than or equal to 9 halves or 4.5. I have to have the most restrictive one. It has to be smaller. I don't really want to use union and intersection. It's too confusing. But if it's smaller than 12, it's going to also be smaller than 9 halves. I have to use this one.
Okay.
Now, it did ask for the maximum value. So let's find it. But I know that 2 has to be it. That's where it has to be where it occurs. So let's find v of 2. I think I have enough room up here. And I'm going to use the factored form because that looks easier. Because it's 9 minus 4, so that's 5, right? And it's 24 minus 4, so that's 20, right? Times 2. Well, what's 5 times 20? 100 times 2 is 200. Did it ask me what the maximum was? Find the dimensions of the box, and then what is the volume. So I do have to know all that. So these are the dimensions. This is the length, this is the width, there's the height. So I answered everything. And you have to prove it's a maximum, and I did because I did this little chart here, and I used the maximum existence theorem.
So how did you get those points?
I'm sorry, what?
How did you get the 5?
I just substitute 2 right back in there. That gives me the length. So it's 9 minus 2 times 2 is 4. Okay? That's my AB. That's my interval. Yes. You don't have to say maximum existence theorem on the exam. You can just use it. Maximum value, yeah. They ask for the maximum volume. And they're not going to trick you. They're not going to say, what's the minimum volume? I mean, especially if it's not a closed interval, if it's a maximum, it's going to be a maximum. I'm glad they don't trick you. I wouldn't put it past them. Okay. Ready to try another one. Remember, now, what you did last? Now, okay, here, listen up carefully. If this were the problem on the exam, and it's in the calculator section, if that happens, would you be allowed to just graph that? No. You have to show the calculus. You can only use your calculator legitimately without showing calculus for the derivative at a point, for finding the intersection of two curves, for finding the zeros of a function. And there's one other thing, we haven't done it yet. Okay. Yes. Remember Di Lorenzo. I'm glad somebody knows who he is. has 10 meters of wire fence. I used to live on a farm and I had horses. And trust me, you want to make sure the horses stay in the pens because it's not fun catching them. Because you walk up to them and you reach for them slowly. You say, nice horse or whatever. The minute you're within that close, they bolt. I spent like 3 hours, didn't even know 3 hours had passed chasing the stupid horse. But then finally she let me catch it. They're terrible to catch. So Farmer DiLorenzo, he wants to put these fences up. And he's going to build 2 identical adjacent pens right here. And what are the dimensions of the total enclosure for which the area is a maximum? I guess I go right to this sentence. I want the area to be a maximum, and I write down what that formula is. Because how do you find the formula of area of a rectangle? Sorry. Length times width. So in terms of my picture, what's the length? 2y. And the width I call x. Then if you look on the back page, and I can go back to this, there's a piece here that says, find an equation you want to maximize or minimize. Sorry, it's typed wrong, but I did that. If you have more than 2 variables, you have to get rid of one of them. So you're going to have to find another relationship. That's what gets tricky. I don't want y or I don't want x. Well, this is x, and this is x, and this is y, and this is y. I need another piece of information, but I haven't. I have 10 meters of wire. I want the maximum area. Okay? So this is the wire that's going to go around all these places. I'm looking for perimeter, aren't I? So what does 10 equal? How many y's are here? Oh, careful, you got to get all these pieces. 4y plus 2x. And we did that. I took my horses down and my cousins down in, 3x, down in Rochester. And we did this with the electric fence because it's x. You got to have the wire here. And that's the wire my horses went through. And then this one. There's 3 of those pieces. So you have to just add them all up. Now, do you want to get rid of the x's or the y's? If I do x's, I'm going to have thirds. I don't like thirds. How about the y's? Third? Nope. I just have to get rid of one or the other. It really doesn't make any difference, although sometimes it's easier than the other. I'd rather get rid of the y. So if I solve this for y, I get 10 minus 3x equals 4y. And if I'm clever, I can see I have a 2y there. But we're not going to be clever. We'll just go right into this. Divide by 4, divide by 4, divide by 4. So this gives me 5 halves, right? Minus 3/4 x equals y. And I'm going to go ahead and substitute that in here. That's what I want. I want my area to be only one letter. I don't care which one it is. Although some are easier than others.
Oh, I thought the Jews came out.
They do, except don't forget to distribute. So if I multiply that out, the 2's will go, so I get 5 minus, and I go 2 times 3/4. You guys remember how to reduce fractions? Well, 2 goes into 2 once, and goes into 4 twice. So this is 3 halves. Times x, and it probably looks like it would be smart to multiply that out, because I don't want to use the product rule, although I could. But then that makes things harder than there. So the calculus is the easy part, because we're just going to take the derivative of that. So should we do that and then do our domain? Because I multiplied 2 times 3/4. I reduced, or you could have written it as 6/4, which is 3 halves. I prefer to reduce first, especially if it's complicated. Okay, so what's the derivative of this? This is the easiest part. Finding the equation is hard. Minus 3 halves times 2x. Right, that's just plain old 3, isn't it? So the derivative is 5 minus 3x. I want that to be 0. And in the real world, even these are nice numbers. What's x equal to? Three-fifths or five-thirds? Five-thirds. Okay. Now the max could be at the endpoints. So let's figure out what the interval is. So we have one candidate. Now we've got to get endpoints. Now we're using x's here. So what's the smallest x could be? X has to be greater than or equal to 0. If x is 0, then what's my area? What's a of 0? It's 0. Okay, so what else has to be true? Doesn't the y also have to be positive? Mm-hmm. So I guess we'll come down here and do it this way. Y must be greater than or equal to 0. Is it 10? Well, let's do this. No, it can't be that, but it's even smaller than that. I don't know. It's that equation. So 5 halves equals 3x over 4. That's a proportion. The easiest way to solve that is to cross multiply. So I get 20 equals 6x. That came from my y equation. Remember we had this? And we solved for y. So there was y. And so that has to be also a positive number. Sorry it has fractions. And it's really hard to write these problems so you don't get ugly numbers. And then what do? We divide by 6. So x equals, can we reduce that? 10/3.
Wait.
I cross multiply. 5 times 4. You can multiply by 4. You get the same result. Okay, so it's going to be, x must be, oops, I lost my inequality. Oh, it's okay. It's greater than or equal to 0. This is going to stay here. This is still going to stay here. It's going to stay here, so x has to be smaller than 10/3. You could just, you know it has to be, can't be bigger than that. And so then x is less than or equal to 10/3. And I'm going to do a of 10/3. Anybody have a guess as to what it's going to be? It's going to be 0. If I put in 10/3 right here, so you believe me, I'm going to have to take 3/4 times 10/3. I should get 5 halves. 3/4 times 10/3. What's going to happen to the 3's? Isn't 10/4 the same as 5 halves? Divide by 2. So a of 10/3 is 0. Therefore, what must be true about this 5/3? This has to be the maximum. This is where it occurs. Maximum occurs here. But if you substitute it into the area formula, right in here, 10/3, that'll make this factor 0. You can use a calculator and just plug it on your calculator, but this would be a non-calculator question. This way or this way? You know, you don't have to close the interval, but it's a guarantee. So it's much easier. They do expect you to close the interval. Otherwise, you would have to do a first derivative test, and you would have to argue that there are no other candidates. So that's harder. To me, it's harder. Okay, and does it ask for the area? What's it ask for? What are the dimensions of the enclosure? Didn't ask for the area. So what's x? X was equal to what, 5/3? Right. And then we have to figure out what y is. So I'm going to have to take this and put in my 5/3 there. It's not going to be that bad. So it's 5 halves minus 3/4 times 5/3. What happens to the 3's? They cancel. So I'm going to get 5 halves, which I don't like writing it like this, minus 5/4. Common, and now that would be okay. If you were doing the problem, actually this would be okay, without even reducing it. But if it's on the multiple choice, no, it's not okay. So it's 10/4 minus 5/4, which gives you what? 5, whoops. Sorry, I wrote it wrong. Said it right. 5/4. So the pen has to be 5/3 by 5/4. Oh, you're right. That's y, isn't it? This is the y value. I answered the question wrong. Y is equal to 5/4, but how big is the side? It's 2y. Oops. I don't think they'll do that to you. They could. 2y then would be 2 times 5/4. Or 10/4, or 5/3. What kind of picture is this? Maximum area is a what? A square. I had to double that number. So it's x is 5/3 and this is also 5/3. It's a square. Your maximum area is a square. Oh, did I get it wrong? Dang it. Right, it's 5/2. And I lost my point. It's 5/2 by 5/3. And the reason why it's not a square is because of this little segment in there. But if you wanted the maximum area, it'll be a square. I had to find what this side was. This side is 2y, right? And y was 5/4. What was 5? 5/4, right? Which is 10/4, which is 5/2. Down here. Remember this one? Yeah, there's a lot of steps here, aren't there? No, you want to find the dimensions. We found x, which is 5/3. We found the 2y, because I forgot to do the 2. And then, if you wanted the area, what would you have to do with 5/3 and 5/2? Multiply them out. They didn't ask that, though.
We don't have a place to put the y.
Yeah, we do. When I put x as 5/3, I put 5/3 right here. And it's 5/2 minus 3/4, that's 5/3. And then this side is 2y. This smells easier. Okay. Ready for the last one? No, it's okay. I was thinking I could skip it and do a different problem. If they're not negative, then they could be 0. I'd like to have it open. I mean, closed. 2 non-negative. Okay, so here's just a number problem. Let x equal the first number. And it's not negative, which means x is what? Greater than or equal to 0. What do you want to call the second number? Second number. Now, if I just had 2 numbers, and I didn't say if they're negative or positive, then we'd have an open interval. So y has to be greater than or equal to 0. And then I'm going to read the question. It says the sum of the numbers is 10, and the product is a maximum. So I look for what is it I want to maximize. I want to maximize the product. So how about I let p equal the product? Because I don't really care what letter that is. So how do you find the product? What do you do with x and y? Multiply them, right? I want the product of my 2 numbers to be a maximum. I got to get rid of x, or I've got to get rid of y. I don't want both. That's right. We have another relationship. They have to tell you this or we're done. The sum of these 2 numbers, x plus y, equals 10. So you want to get rid of x or you want to get rid of y? It doesn't make any difference. Okay? So y equals 10 minus x. And you substitute it in here. And so my product now is x times 10 minus x. So p is equal to 10x minus x squared. Okay, you guys want to take the derivative right away or find the domain? I almost have it. I have part of it. X has to be greater than or equal to 0, y also has to be greater than or equal to 0. So here's y. So 10 minus x has to be greater than or equal to 0. Highest number is 10. So the interval is 0 to 10. Okay, so let's take the derivative. So I've got two candidates right here. And so p prime, is equal, this is going to be easier with arithmetic, is what? 10 minus 2x. I want to know where that's 0. And where is that 0? At 5. That shouldn't surprise you. You could make a list of numbers, but that won't give you any points. Okay, so how do I find out? S says, what is, I want to find the two numbers. So here are my candidates. Now I'm going to do this a little differently just to show you another way you can do this. Here's your product. Here are your values. Here are the endpoints, 0, 10, and we have where the derivative is 0, and here's the product. Okay? So p is equal to x times 10 minus x. If x is 0, what's the product? 0. If x is 10, what's the product? 0. If x is 5, then I get 5 times 10 minus 5, or 25. It asks what the numbers are. They're 5 and 5. What's y? Y is what? 10 minus x, right? So y equals 10 minus 5. You see why I gave you so few problems? They take a while, don't they? Yeah. No, I took out the ones with all the parts. You know, I think the parts are more confusing than just doing the problem. And x equals 5, but that shouldn't surprise you. If you had two numbers, if you just had integers, you could have 1 and 9. That gives you 9. And then you'd have to go smaller numbers, actually. And then 2 times 5, 2 and 8, sorry. Then their product would be 16. Then you would have to do 3 and 7. Their product is 21. And you would do 4 times 8. Their product, 8. I can do this. It's 24. And then 5 times 5 is 25. Those are just the whole numbers. So you would have to deal with the fractions and the decimals as well. Okay. Yes. No. Remember what I said about the homework? It's just those 5. That's all. We're only spending one day. And then tomorrow, we'll do questions on that. And then... Yes, we have all that stuff to do. 4-5, 2 days on 4-5. And our favorite section, 4-6, notice the emphasis on 4-6. That has been a free response question in the past, but not recently. It's called the related rates.
Maybe that's what the top of the test.
No, I'm telling you, one of these on this page is on the test. Pardon?
The guy that came at top domestic related rates.
They are very similar to this, but you'll like related rates better. Oh, yeah. No, you have to read the question. If they ask for the product, you have to give it the product. That's all. If you haven't, I mean, I could do one of these problems, but you can give it a try. Try it. They should be online. If they're not online,